Hello everyone, I'm Sasikanth, the Technical Associate for GITAM IEEE Student Branch, Visakhapatnam. I'm here to demonstrate about 3 basic Arduino projects. So let's begin. So here's my first project, which is Arduino based PIR sensor, where we are going to demonstrate about the working model of a PIR motion sensor using Arduino. In this project, we will learn about PIR sensor and how it can be used as a motion sensor through this tutorial. By going through this project, you can understand how PIR sensor works and how to integrate a PIR sensor to Arduino. So let's get on to the overview. A PIR sensor or a passive infrared sensor is an electronic device that measures the infrared light emitted by the objects in its observable area. The term passive in the PIR sensor indicates that the sensor actually doesn't emit any infrared light, but rather passively detects it that is emitted by its surrounding objects. Every object with its surface temperature greater than absolute zero, that is minus 273 degrees centigrade, emits heat in the form of infrared radiation. Humans cannot see this radiation as the radiations are in infrared wavelength, but PIR sensors detect these radiations and change them into appropriate electrical signals. So, how does a PIR sensor actually work? PIR sensors are complicated than most other sensors. Motion sensor may seem simple when implemented, as you all need to do is check for a high signal on the digital out pin of the sensor whenever motion is detected. But internally, there is a lot going on and the input and output of the sensor are dependent on several variables. The actual PIR sensor, that is the one which is covered with a lens, consists of two slots and both these slots are made up of IR sensitive materials. Under normal condition where there is no movement in front of the sensor, both the slots in the sensor detect same amount of infrared radiation. When there is movement in front of the sensor like a human or a cat, the radiation is interpreted by one of the slots first and the differential output between the two slots becomes positive. As the person moves away, the second slot detects the radiation and it interprets the differential output and the differential output will become negative. Based on these output pulses, a motion is detected. So here's the circuit diagram which clearly explains about this project where we are going to use namely three components: Arduino Uno, 5 volts buzzer and a PIR motion sensor. So let's get on to the simulation. We have used Tinkercad software, which is an open source software available on the internet. So we need to have three components. The first component is a programmable component and we all know it is a simple Arduino Uno R3 board. And the second component is a piezoelectric material, or to be more precise and to be more appropriate, let's call it a buzzer. And finally, the most important component required for doing this project, which is the PIR sensor. Well, here comes the most exciting part of this project. What is it exactly? Connecting the appropriate terminals to the Arduino board. So firstly, I have connected the positive terminal of the buzzer to the 11th digital pin present on the board, which is the Arduino Uno board. And the negative terminal is connected to the ground pin of the same board. And now getting on to the PIR motion sensor, we've got namely three terminals: signal, power and ground terminals. And these three terminals have their own specific purpose. The signal terminal is used for determining the amount or the range of signal that is to be interpreted by the motion sensor, that is the electronic signal which the motion sensor gauges from the physical changes in the surroundings, signal terminal, and that is connected to the 8th digital pin on the Arduino board. and the power terminal is connected to the 5 volts terminal present on the board. And finally, the ground terminal is connected to the ground pin which is available on the Arduino board. So now we have completed connecting the components, and now let's get on to the code part. Let me convert this into text. And yeah, we have ready-made code available as an open source code on the internet. Here's the required code. So firstly, we have two components, or that is two components which are connected to the programmable component. The first thing is the buzzer, which is connected at the 11th pin, and the sensor is connected at the 8th pin. Now let's get on to the setup. Here in the setup, we have defined the function for each component, that is the buzzer as well as the sensor. The pin mode is used to determine the output or the input of the components, and the digital write is used to set the buzzer to a predefined state at the start of this project. And then we have defined a while loop based on a condition where the sensor gives the electronic signal and the electronic signal is interpreted by the board, and accordingly the piezoelectric material, that is the buzzer in our project, would be working. And finally, this is the loop function where we have defined a condition where if the sensor gets high, that is if the sensor gives you an electronic signal giving a high output, then the digital write of the buzzer should be high and there should be a delay of 3000, that implies 3 seconds. And if the digital write of the buzzer is low, digital read of the sensor is high, then the loop will be again repeated, and this goes on and on until we stop the simulation, right? Now let's get on to the simulation part by running it. As the obstacle is out of range, here the buzzer would be in low state, so as a result there would be no sound of buzzer. But as soon as the object enters the range which is covered by the PIR sensor, the buzzer would be in high state as a result of the electronic signal sent by the PIR motion sensor, which is also high. So yeah, this is my first Arduino project and it is quite a simple one. Now let's get on to my second Arduino project, which is also a basic one. So here's my second basic Arduino project. So what is it? It is a DC motor which is being controlled using Arduino. So what is exactly a DC motor? A DC motor is a type of electric motor that converts DC electrical power to mechanical power. That is, a DC supply is converted to rotation or movement. DC motors are one of the most commonly used motors in different applications like electronic toys, power tools, portable fans, etc. DC motors are also used in robotic and industrial applications for their easy control and precision. So here's the circuit diagram which is depicting the working of our project. So now let's get on to some fun stuff. So yeah, here's the circuit design which has the Arduino DC motor. Well, this project has the most integrable component, which is also known as the programmable component, that is the Arduino Uno. And we have a PNP BJT transistor here, and this is a resistor, and this is a diode. And finally, we have the most important component to perform this project, which is the DC motor itself. So now let's get on to the code. What is the code for this? So this is the code. So here we have the same old functions defined here, which is setup and loop. And in setup we have the pin mode 9, which is depicting to output. And we have the function loop where we are going to specify a for loop, which in turn depends on a condition. So yeah, let's get on to the simulation part. So as you can see here that the DC motor is rotating and the RPM is shown over here. Let me rotate this if I can. Yeah. as the connections are in reverse order, here the negative symbol is shown. So the rotations, as we all know, are measured in RPM, that is revolutions per minute. So this is how we control a DC motor using Arduino. And how are we going to control that? We are using some components, key components, a PNP BJT transistor and a PN junction diode. So that is it. This is the simplest way where we can implement the working model of an Arduino DC motor. We have the final project, or the third project, which I'm going to demonstrate, and that is control a servo motor using Arduino. So let's begin. What is a servo motor? A servo motor is a type of actuator that provides high precision control of linear or angular position. A typical servo motor consists of four things or parts: a DC motor or AC motor, a gear unit, a position and speed sensing device, and a controlling unit. Servo motors are used in applications where very high precision motion is required, like assembly robots, computer numeric controls, etc. Servo motors are available as both AC servo motors and DC servo motors, with each type having its own areas of applications. Typically, simple servo motors consist of 3 wires. These are usually color coded as red, brown, and orange, and it may vary with different models. The red wire is used for supply, the brown wire is used for ground, and the orange wire is used for control signal. A simple servo motor, as the one used in this project, consists of a small DC motor and a potentiometer for providing position feedback. So this is the required circuit to implement the working model of a servo motor. Here we have an Arduino Uno, a servo motor, and this is a fascinating component which is used in this project. This component is called a potentiometer, that is variable resistance, and this is used to determine the amount of current which flows into the servo motor. Let's get on to the code, and here we have the included file servo.h, and we have a value which is given as an input, and we have an angle data type of double, and here we have the same two functions, setup and loop, with a different purpose. In the setup function, we have the serial.begin and myservo.attach. The void loop function contains the values which are to be taken as an input from the potentiometer. That is, the potentiometer decides the amount of current that is provided to the servo motor. So now that's enough with the code, and let's start with the simulation. So as we can see, the servo motor has given a slight rotation, and by varying the potentiometer, it rotates, and in this manner the control of servo motor is achieved. So this is it. Hope you all enjoyed my video, and if you have any queries, please feel free to comment in the comment section below. Until then, stay safe and enjoy learning.